So this lesson right here is called Proving Lines Parallel. I don't know if you remember, at the beginning of the year, I said we're not really going to do proofs in here. We're not going to do formal proofs, and we're not going to do a formal proof on this lesson either, even though it says Proving Lines Parallel, right? So don't get too scared off by that. But we did learn some stuff before this lesson about parallel lines. Seems like it's been a while since we've done real stuff in here with Spirit Week last week and all that kind of good stuff. So let's review just a little bit. All right, so this isn't technically section 3.2. This is from 3.1, but we're just going to review just to jog our memory just a little bit.
Yeah, I get it.
All right, so first of all, these are parallel lines, right? These two lines? How do you know?
Because they don't have to.
That's right, very good. You didn't fall for it. So if you put a little arrow there, a little arrow there, now, are they parallel lines? Yeah, absolutely. What's this line that crosses those two lines? Those two parallel lines? A transversal. No. This is a transversal. So we have a transversal that crosses or intersects two parallel lines. So we had several, four different things that we knew about it. I think one was a postulate. We had 3 theorems that we talked about this situation. So if I number these, this is just review. It's not brand new. So we start off saying what? If we have two parallel lines. That's the difference between what we're going to learn new today and what we learned in section 3.1. In section 3.1, they told us the lines are parallel. Everybody hear that?
Yeah.
All right, so they told us the lines are parallel. This is obviously a transversal. So if the lines are parallel, we know something about some of these angles. Let me scooch this over a little bit. Give me some room to write. All right, so here we go. So let's talk about some of these angles. So I'll tell you what, I'm just going to mark them. I was going to write them down over here off to the side. Let's just mark them in the picture. All right, let's take a look at angle 1. Let's just give that one arc right there. So you should be able to tell a bunch of things from angle 1. If these are parallel lines and this is a transversal, you should tell me some things that are equal to angle 1. So give me one of them. 5, okay, 1 and 5. Give me a reason though. I want to back up everything that I say here because they're corresponding angles, right? And we had a postulate. It was actually a postulate that says if you have two parallel lines cut by transversal, then the what? Corresponding angles are equal to each other. Okay, good. So 1 and 5 are corresponding. Since we're talking about corresponding, what are some other corresponding angles? 3 and 7, okay. So I'm not going to put just one arc there because that already had one arc. So what am I going to do with this to show the difference? Yeah, put 2 arcs here. So 3 and what? 7. Yep, they were equal to each other. What else?
1 and 8.
2 and 6. But what's also equal to angle 2?
3.
Angle 3. Why are they equal to each other? Because they're vertical angles. Exactly right. That's not one of our 4 things that we learned, but it is a separate thing that we learned, that these angles that are across from each other are called vertical angles. So they're equal to each other. So since that's got 2 arcs, I can put 2 arcs there. Agreed? So what else do we know about angle 2? Angle 2 is also equal to what else? Angle 6. Give me a reason why 2 and 6 are equal. Again, corresponding angles. Okay? Well, what's equal to 7? 6 is equal because they're vertical angles. Listen, 7 and 6 are equal to each other because they're vertical angles. Right, and 2 and 7 are equal to each other. Now, give me a reason why 2 and 7 are equal to each other. You could say 2 is equal to 6, right, because they're corresponding. 6 is equal to 7 because they're vertical. Therefore, what? 2 is equal to 7. We actually have a name for that. We call it the transitive property. We're not going to worry too much about that right now, though, okay? But 2 and 7 would be equal to each other. Now, let's do the other ones. What about 4?
8 and 1, 5.
Okay, 1 and 4, right? Why 1 and 4?
They're vertical.
Vertical angles, right? 1 and 4 are equal to each other because they're vertical angles. So that, and what else do we know about 4? 4 and what?
8.
8. And why are they equal to each other?
They're vertical.
4 and 8?
Horizontal.
What?
Corresponding.
They're corresponding, right? We've done 3 of them already, right? So 4 and 8 are corresponding angles, and so they're equal to each other. There's some other stuff. Now, we got all the stuff marked that are equal, correct? But give me a reason. Look, 3 and 6 must be equal to each other because they both have two arcs, right? From all the other stuff that we said. But give me the name of the theorem that says that 3 and 6 are going to be equal to each other. What's the relationship between 3 and 6 right here?
3 and 6 are equal to 2.
No, between just 3 and 6. They're equal to each other, but what's the relationship? What's the name of the relationship? They're alternate interior angles. That's right. 3 and 6 are alternate interior angles. And anytime you have two parallel lines cut by transversal, the alternate interior angles are going to be equal to each other. Give me another set of alternate interior angles. 4 and 5, okay? And again, I'm harping on this because what we're going to do here in a few minutes, okay? We start off knowing what? What do we know starting off about the lines? They're parallel to each other, okay? We know, they told us, it's given that these two lines are parallel to each other. If the lines are parallel to each other, then all this other stuff is true, okay? Let's list them. All the corresponding angles are what?
2 and 6.
No. Don't list them. Give me the word. What are all the corresponding angles? They're equal to each other, okay? What are the alternate interior angles? They're equal to each other. We kind of talked about 2 and 7, but we didn't give the name for that. What's the relationship between 2 and 7? What are they? They're alternate exterior angles. And what are they? They're equal to each other, okay? So 3 things are equal to each other. The corresponding, so 1 and 5 are corresponding, 3 and 7, 2 and 6, 4 and 8. They're corresponding angles. They're all equal to each other. The alternate interior angles are equal. Let's list the alternate interior angles. 3n, 6, 4n, 5. Okay, they're equal to each other. What about alternate exterior angles? Angle 1n, 8, and 2n, 7. Everybody got it? All right, so we know those 3. One was a postulate, the corresponding angles. The other 2, the alternate exterior, alternate interior, were theorems. But we had one more. But all 3 of the ones we just talked about, they are all equal to each other. This is the one that's not equal to each other. Do you remember that? What are they? That's right, like 4 and 6. What? I'm in the middle of doing something. Does that not occur to you? I mean, it's just like a crazy question out of the blue. Have I ever made you put it in there? So why would I, in the middle of a lesson, you do that again, you're out of here. I know you're doing it just to get me doing what I'm doing right now. Okay? So let's talk about 4 and 6. Okay? And I said it already. What are they? They're what? They're consecutive interior angles. Okay? So again, we start off knowing that you have parallel lines and we have consecutive interior angles. Now, they are not equal to each other. I mean, look at it. This has 1 arc, that has 2 arcs. This one is obviously what kind of an angle? It's obtuse, and this little 6 right here is what? Acute. Okay, so they're definitely not equal to each other. What's the relationship between 4 and 6? They're not equal. They're what? Give me a word. Give me a word. They're supplementary. That's right. They're supplementary. All right. What does it mean to be supplementary? They add up. Don't say they equal 180. All right, because that might mean that 4 equals 180 and 6 equals 180. But they do what to equal 180? They add up to be 180, okay? Their sum. You ever hear that? I don't think I said that in here yet. The sum of the angles is 180 degrees, which means when you add them up, it's equal to 180. Everybody with me so far?
Yeah.
That's all review, right? We've already done that. Have we had a quiz on this? I don't think we had a quiz on this yet, no. But we will eventually. Do we have a quiz this week? I don't think I wrote down a quiz this week, did I? Did I? Okay. So that's what we've learned so far about parallel lines. But now let's change gears a little bit and let's draw 2 lines. Are they parallel lines?
No.
That's a what? Transversal. Okay. Let's put the same exact numbers in here again. Is that the way I wrote the other ones? I think. Now look, we do not know that these 2 lines are parallel to each other. There's no arrows. That's right. Okay. So I don't know that they're equal, that they're parallel to each other. But here's what they're going to do. We are going to show, or we're going to prove, that these 2 lines actually are parallel to each other. Let's call this line A and line B. Okay? I could put arrows on the ends to show that they're lines. I'm just too lazy to do that right now. I don't need to. Okay? Now, here's what they do. I'm not going to write out the whole theorem for you because we kind of wrote them out before. But this one doesn't start off saying if two parallel lines are cut by a transversal. This starts off just saying if two lines, just general lines, are cut by a transversal, and the corresponding angles, if the corresponding angles are equal to each other, okay, so if they tell me right off the bat that angle 1 is equal to angle 5, they tell me that, all right? So they might, sometimes you'll see this, given, you'll see angle 1 equals angle 5. What do you think I could say about lines A and B? That they're, well, not equal. Lines aren't equal to each other. They're parallel to each other. Exactly right. Do you follow? Do you see the difference? It's a subtle difference, but it's still a pretty big difference. The first time we learned this, what did we say? If what? If two parallel lines then are cut by transversal, blah, 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 then the corresponding angles are equal. Agreed? This one doesn't say that. This one says if you just have two lines and they're cut by transversal, and if you notice that the corresponding angles are equal to each other, or if they tell you, notice, whatever, figure it out, if the two corresponding angles are equal to each other, then what can you say about these two lines? They must be what? Parallel. Do you see the difference? We kind of switched the if and the then, right? So instead of saying if two parallel lines, or if two lines are parallel, then the corresponding angles are equal, we switch it and we say what? If the corresponding angles are what? Equal, then the lines are parallel. Do you see the difference? Okay. That's called the converse of each other, by the way. We'll talk, I don't know, maybe we'll talk about that. I think we do talk about this later on. So, that's a postulate. If the corresponding angles are equal to each other, then the lines are parallel. So what else do you think might follow from this? What else? Let's do this. Well, vertical angles really don't have anything to do with lines being parallel. So let's stick with the two angles that could be equal to make the lines parallel. So 3 and what? You could say 7, but we've already established the corresponding angles. So we're not going to do any more corresponding angles. 3 and 6, that's right. Okay. So if I told you that angle 3, you don't have to know both of these. These are just kind of separate. Okay. So if I told you that angle 3 is equal to angle 6, then what do you think you could say about those two lines? Then they're parallel to each other. Okay? What if I told you that 1 and 8 are equal to each other? What could you say about these two lines? They're parallel. Why? Because 1 and 8 are what? Alternate exterior angles. Okay, so again, we have a theorem that says if the alternate exterior angles are equal to each other, then the lines are parallel. Yes? So that covers all the stuff that's equal to each other. What's another thing I could say, though? 7 and 2? They're alternate exterior. We already said alternate exterior. 4 and 6. What's 4 and 6? What are they to each other? That's right. So if angle 4 is what to 6? Is equal to? Give me a word. If 4 and 6 are what? Supplementary. That's right. If they're supplementary. So if angle 4 is, I'll just shorten supplementary. Is that all right? If angle 4 is supplementary to angle 6, what does that mean when I say they're supplementary? What does that mean? They add up to 180. Right. Okay. So if angle 4 is supplementary to angle 6, then what must be true about the two lines? They must be what? No. Lines. The two lines together, they are parallel, right? Then, so what can I write? A is what? Parallel to B. Remember the parallel symbol? That's what parallel means, this thing right there. So if angle 4 is supplementary to angle 6, then A and B are parallel. Let's just do one set of corresponding. Give me a set of corresponding angles we haven't talked about yet. Corresponding, yeah. 2 and 6, okay. So if angle 2 is equal to angle, oops, sorry, I put angle 6. That's all right. It doesn't matter. since I said 2 first, we'll do it. If angle 2 is equal to angle 6, then what must be true about the two lines? A must be what? Parallel to B. Agreed? All right. So this is the consecutive interior. This is the corresponding. Let's do one for alternate interior. Give me the set of alternate interior that we haven't talked about today. If what? 4 and 5, yeah. So if angle 4 equals angle 5, oops, my pen would write. Let's try this again. Angle 5, then what do you think? A must be what? Parallel to B. Let's do one more. What's the other one? So we got consecutive interior, we got corresponding, we've got alternate interior. What's the other one? Alternate exterior. So give me a set of alternate exterior we haven't talked about yet. 2 and 3. 2 and 3 are not alternate exterior. 2 and 7 are alternate exterior. So if angle 2 is equal to angle 7, then what? Talk to me.
A and B are parallel.
That's right. A is parallel to B. Okay? Again, this is because of what? Consecutive interior angles are supplementary. This is 2 and 6, corresponding angles are equal. 4 and 5, alternate interior angles are equal. 2 and 7, alternate exterior angles are equal. So if all that stuff's true, then the lines are parallel. Everybody good? Okay. So let's, where should I go with this now? I think, see, I didn't take any notes on this lesson. I should have. Let me see if there's a good example in here. That might be. Oh, here's another thing we did too. Remember we did. Let's do this. Again, what if I had two lines? I don't know they're parallel just yet, okay? But I do know this. I do know that this transversal is perpendicular to line A, and I also know that it's perpendicular to what? To line B, all right? So if the transversal is perpendicular to both lines, what must be true about those two lines? They got to be parallel to each other. Everybody see that? And what would be a reason? Well, because this is 90 and this is 90, right? They're also corresponding angles with each other. So if the corresponding angles are equal, then the lines are parallel. All right, so it kind of flows from the corresponding angle thing. But it's a specific, it's perpendicular, it's 90 degrees. So we say if it's perpendicular to both lines, then both those lines have to be parallel to each other. We good?
Mm-hmm.
All right. Do you have your lesson plan thing in front of you?
Yeah.
What, I'll tell you what, let's do this. Let's do example 3. Yes.
So the transversal line doesn't have to be slanted.
It does not have to be slanted. No, it could be straight up and down, as long as it crosses both of those lines, all right? I mean, every other time it will be slanted. This is the only time where it won't be slanted, when it's just straight up and down like this, okay? All right. This is going to be a little bit more confusing, so let's, and I'll tell you what I'm going to do. I'm going to draw these lines. Oops, sorry. Let's delete that. Let's copy this and paste it. Try later. Okay. Right there. So let's make these a different color. Let's make them yellow. And then we'll make... Let's lift that up just a little bit. Push it over, push it down. Okay. I'm going to copy and paste that one. There we go. Yeah, it's kind of slanted. That's kind of what I want. And let's change these to, I don't know, blue. Looks like University of Delaware colors. All right. Let's call this... I should have slanted it the other way. That's all right. It doesn't make any difference. Let's make this white. Let's make this 1 and 2. Let's make this 5 and 6. Let's make this one 4 and 3. All right. And let's call the blue one, let's call this A and B. And let's put it up here, put C and D. Okay, there we go. Everybody with me so far? All right. What if I told you, let's turn this back into white. What if it was given that angle 1 equals angle 2? The question is going to say, which lines then are parallel if angle 1 is equal to angle 2?
All four of them. For what? All four of them. Whoa.
Well, what does this line D have anything to do with 1 and 2? Line D's got nothing to do with 1 and 2, does it? So I can't say that the two yellow ones are parallel, because what is the yellow one with angle 1 and 2? Again, let's mark it. Okay. Whoops. Keep pushing that button. Let's try this again. There's 1, and there's 2. So they tell us that 1 and 2 are equal. Okay. So what does that mean about some of these lines? If 1 and 2 are equal, then what?
A and B are parallel.
The two blue ones are parallel. That's right, because look what they connect. See, this connects from the transversal to the blue one. This connects from the transversal to the blue one. Now, they're not going to be color-coded on a quiz or a test or your homework, all right? But I'm just doing this to make it a little easier for us to pick it out, okay? So if you look at this, 1 and 2, which one is the transversal? Which one is shared by both of those angles? That yellow one, line C, all right? So that must be the transversal. So what is the two blue ones? The two blue ones, if 1 and 2 are equal to each other because they're alternate interior angles, right? Then the two blue ones are parallel. So what can I say? Then what? A is parallel or B, okay? You see what they're asking you to do this time? So they don't tell you that the lines are parallel and then figure out what the angles are. They tell you that the angles are either equal or supplementary or something like that. And you got to figure out which lines must be parallel then if they tell you what angles are equal, okay? All right. What if they told you that 4 and 3 were equal? What does that tell you? So which one's your transversal with angles 4 and 3? D. That's right. This one right here. So that must mean the other two lines must be what?
Parallel.
Why? Because what's the relationship between 3 and 4? They're alternate exterior angles, okay? They're alternate exterior angles, and they told you that they're equal to each other, okay? They told you that angle 3 is equal to angle 4. Then what must be true if 3 and 4 are equal to each other?
A is parallel.
Then again, line A must be parallel to B, all right? Now, how many arcs does angle 6 going to have then? Do I put 3? No. I can put what? Why do I know I can put 2 arcs for angle 6?
Because it's corresponding. No, it's vertical. No. Yeah.
They're vertical angles, 6 and 3. Okay, 6 and 3 are equal to each other. Doesn't matter if the lines are parallel or not. Okay, 6 and 3 are always going to be equal to each other. Anytime two lines cross each other, the angles across from them like this, or vertical angles, are going to be equal. So if 3's got 2 arcs, then what's 6 have?
2 arcs.
It's got 2 arcs, okay? What if they told you that angles, actually, we didn't even need to know that, to tell you the truth. I was thinking something else. What if they told you this? See, it's given that angle 6 is supplementary to angle 5. Then what must be true?
So, line A and B.
Again, line A and B. It just seems like we're just kind of saying the same lines, but, and I could put some other stuff in here so we can see that the lines C and D could be parallel to each other as well, right? So 6 and 5, they're supplementary. Again, watch. Boom, boom. Okay, that's got 2. And what do you think? Well, I'm trying to think of, let's just say it does have 1, okay? All right. Well, but the thing is, we don't know that C and D are parallel to each other, okay? But I'll just say it has 1 arc, okay? So we do know that those are supplementary. So 5 and 6 are supplementary. So what can I say then about the 2 lines? Well, then A and B are parallel, correct? Again, because this is the transversal. That's the key. Look to see which one is the transversal. So that must mean the other 2 lines, right, are going to be the parallel lines, right? But what if they told you this? What if they said that angle 2 and angle 6 are supplementary? Then what can we conclude? If 2 and 6 are supplementary, so see, this connects the blue one to the yellow one. This connects that blue one to this different yellow one. Everybody see that? So what do they have in common? What line do they have in common? This blue one, B, right? Everybody see that? So the B must be the what? The transversal. So look at 2 and 6. They're consecutive interior angles, aren't they? And if I told you, I forgot to put the angle right here. There we go, angle 6. All right, so angle 2 and angle 6 are supplementary. Then what can we say? Is it still A and B? It's C and D, that's right, because B is my transversal this time. Okay, and so that must mean C and D must be parallel. So C must be parallel to D. Getting the hang of this? Okay. Let's call this 7 right there. Let's put 1 arc there. So if 2 and 7, what if I told you that angle 2 equals angle 7? Then what can I conclude about some of the lines? 2 and 7.
5 and 1.
Now, what can you conclude about the lines, not the angles? What are parallel?
Yellow.
The 2 yellow ones, the C and the D, right? Because for 2 and 7, they're alternate interior angles to this transversal, this blue one right here, okay, line B. So 2 and 7 are alternate interior angles, so this is my transversal, so that must mean C and D would be what? Parallel to each other. Yep.
I was gonna say, like, before you got to the 7, I was gonna say then there would be something for 1 and 5.
Yeah, exactly right. Okay, if I told you that 1 and 5 are equal to each other, absolutely. If I told you that 1 and 5 are equal to each other, this is my transversal, right, for 1 and 5. So what are the 2 other lines? C and D, exactly. Yep. I mean, you could do a whole bunch of different ones in here, right? Name all the angles, figure out all the corresponding alternate interior, and so on. But that's basically what they're going to ask you to do. But they're going to get a little bit trickier, all right? They don't do this in any examples. I'm really surprised that they didn't do this as an example. But I'll tell you what, let's just do... When do we get out of here? 20 or 40? Or is it 50? Is it 50? Oh, cool. All right, we got time then. So let's do number... Do you have your book open? Look at number 15. I'll draw it for you. It's page 117. So it's section 3, section 3-2.
Did I use the bathroom?
No, just wait.
Please, it's an emergency.
I'm sure it is.
No, I actually have to go.
I said I'm sure it is.
I'll be 3 minutes.
No, you're fine. Now I'm not going to color code these. Oh my, they put, well, I'll tell you what, I'm just going to name the angles that they give us. So number 15, they tell you angle 5. So angle 5 is this one right here. And angle 15 is this one right here. Okay? And here's what they tell you. They tell you, let's put it over here. They tell you that angle 5 They kind of tell you what angle 5 is equal to. It's 2x minus 3 degrees. All right, they kind of tell you angle 15. And that's 2x minus, whoops. That's not really what I thought they were going to do here. See, if I was giving you problems on here, I would not give you the problems that they did on here. You know what I'm going to do? Instead of giving you this homework to do, I'm going to give you a worksheet. I don't think I told you to do a worksheet, did I? On the lesson plans? Okay, but I think I have it. I think I have it printed out because when I did this, I think I have it. Let me see.
Yeah, on Tuesday.
Does it say proving lines parallel worksheet?
No. Oh, yep.
Oh, it does?
Yeah.
Okay, because I don't have that thing in front of me. So I'll tell you what. Take one of these. Actually, yeah, take one of those, pass them around, or you can just pass it. You can get up and pass it to everybody if you want. I like these problems better. So let's do, instead of this,
Can I fill my water bottle up,
no,
please?
no.
I'm thirsty.
You should just put the bathroom.
She makes perfect sense. The first page is really, really easy. I'm going to look at number 12 on the worksheet that I gave you. Yep.
No, number 13.
This is kind of more of the problems that I would want to give you. All right, here's what the problem says. It says, find the value of x. I'm just going to say find x. That makes the lines parallel. That makes, they call it lines U and V. So U and V parallel. All right, this is line U. That's my lowercase u, and that's just a regular V. All right, lowercase v. So what are they asking you to do? Did they tell you that those lines are parallel right off the bat? No, they don't. Okay, they want you to find what x should be equal to, right, in order to make those two lines parallel. So what must be true about these two angles then? If these two angles were what, then the lines would be parallel. Well, they are corresponding angles, but if they were what? Supplementary, equal, what? They're corresponding angles, so they're not supplementary. What are supplementary? Consecutive interior. What are these? They're corresponding. So if the corresponding angles were what? Equal, then the lines would be what? Parallel. So what do you think we're going to do with these two angles? Set them equal to each other. Exactly right. Then solve for x, and then that's what x would be equal to. When it says find x, that's what x would be equal to make these two lines parallel. Okay? So if I find what x is, I could always put them back into this and this, then the angles would be equal. That would mean that the lines would be parallel. That's what we're trying to do. Find x so that it makes lines u and v parallel to each other. All right? So really, it's pretty simple. Pretty simple algebra. Nope, it just says to find what x is. It doesn't even ask you to find the angles. But we're going to just to show you that it'll make those two angles equal to each other. And if those two angles are equal, that must mean the two lines are parallel. All right, so 12x minus 4 equals what? 10x minus 10. All right, we can do this pretty easy, can't you? Subtract 10x from both sides. Add a 4 to both sides. That should be second nature to you now, right? So 2x equals, that cancels, what's that? Negative 6. So x is what? How about negative 3? That's all right. Divide by 2.
It's
All right.
7.
So x would be negative 3. Did I do that right?
No.
I don't think I did that right. What did I do?
Isn't it minus 4? It's you made it negative 6 instead of 14. Oh wait.
Yes. Because the
Yeah,
10
'cause the 10 was plus 10.
Yeah, plus then you put minus.
Oh, it's plus 10. No wonder. Okay. Well, I did that problem right. I actually did this problem right. But yeah, she's probably looking at the problem that's actually in the worksheet. And I messed up. That's my fault.
Hey, don't say that.
Stop. She was absolutely right because she was doing the problem that was actually on the worksheet. I'm the one that messed up. I'm the one that wrote it down wrong.
Hey, it's okay. Don't
So
make mistakes.
that's fine. I'm just owning up to it. So this was a plus 10. My bad. I just wrote it down wrong. And then, so that's 14 divided by 2. So x is 7. All right. That's what they want right there. Right. But they're getting it a different way. Like before, when you did that other one, what would they say? They would say, these are parallel. Find what x is. All right. The math is exactly the same. But what you're trying to find, Logan, look up here. The math is exactly the same, but what you're trying to find is a little different. It's a subtle difference, but it's definitely different, okay? So what they're doing, they're saying, what should x be in order to make those two lines parallel? Because we don't know they're parallel to begin with, all right? You see the similarities, though, obviously, right? I mean, they're almost, a lot of people just look at these and say, oh, yeah, it's the same exact type of problem we did before. No, it's not exactly the same. It's slightly different, all right? So now, if x is equal to 7, then guess what's true about these two lines? Then they're parallel to each other. Everybody see that?
Yeah.
Because what does it do? It makes 7 makes this angle equal to this angle. And if you wanted to plug 7 in, what would it be? What's 12 times 7? 84 minus 4 is 80. All right? Plug a 7 in for this. 10 times 70, and this is supposed to be a plus 10 because I wrote it wrong. Plus 10 is 80. So sure enough, these two angles would be the same, which means that the two lines must be parallel. So that's what they're doing, okay? So, again, I don't have the... Let's see. So does that change our... Oh, yeah, I do give it to you. So, I'll tell you what. Let's do section 3.2. Okay. So let's do that, and then tomorrow I'll let you do that worksheet. You got the worksheet in front of you. So if you want to do them both tonight, you can. If you just want to wait and do the worksheet tomorrow, you can do that as well. But let's do 3.2 tonight. Okay. So that's 1 to 22. So it's 1 to 22, and it's section 3.2, and I believe, yeah, that's all we're doing for 3.2. So there's no A and B to 3.2. Okay, it's just 3.2. It's page 116, 117. It's pages 116 and 117. I think that's everything right there. Okay, and then the worksheet where number 12 was part of. We'll just do that tomorrow. Okay, everybody good? All right, that's all I got.